Hi everyone, my name is Vanessa Freudenberg and I'm going to talk about SqueakJS, which is an interesting virtual machine for Smalltalk. The interesting thing about it, it's written wholly in JavaScript, but it's running a real Squeak image, quiz image, even some Pharaoh images. So it's for the Squeak family of Smalltalks. You know, it's kind of the great ancestor of a lot of fun Smalltalk projects. It's implemented in JavaScript and runs in a web browser, even on a phone. If you just scanned that QR code, you could have Smalltalk running on your phone right now. Did you? No. You wanna take a photo? Here. Okay. So it just goes to squeak.js.org. You can also just Google SqueakJS, it's the same. But the interesting thing is I started on this project in 2013 in December, and it took only like 3 weeks or so to get the first pixels on the screen. And so it really, the bulk of the work of the original implementation was done in 2014. And this year I didn't really do much on it, so that's why I'm saying it's a decade. Might be a little bit more. It's practical enough for various applications. We saw some code paradise things today at this conference, which is using SqueakJS in the background. There is Craig Letta's work on caffeine. He built a whole like 3D environment where he's using that stuff, and it's open source, it's MIT licensed, and I've had quite a few contributors. And the most visible deployment maybe is in Dan Ingalls' Smalltalk Zoo. If you have seen that, if you Google Smalltalk Zoo, you will find it. It's actually at the Computer History Museum. Here, this is the URL. Smalltalk Zoo at computerhistory.org. And you can run Squeak, which Dan in his paper called Smalltalk 96. So that's a kind of funny thing to do. Going back to my presentation. So in 2013, I started. The original bytecode interpreter was based on Potato, which is Dan's Java VM that he had at some point. New interesting things about that are actually in the paper is the garbage collector. So the whole design around SqueakJS is trying to leverage as much of the JavaScript host environment as possible. It's a very fast JIT compiler, right? So current JavaScript VMs are very, very fast. And they have very good garbage collectors too. So I'm not going to go into the details here because you can read that in the original paper from 2014, which actually won last year's most notable paper award for papers that came out 10 years ago. And so it was apparently quite influential in some thinking. And just, oh, I wrote it down here, okay. So the virtual machine, my virtual machine, manages old space, so it's just a linked list of objects. But new space is wholly managed by JavaScript collectors. And as we learned the other day, most objects die young. So this is a very, very efficient way of doing it. So JavaScript objects, Squeak objects are just created, and they go away without having to do any manual garbage collection. Where the garbage collection comes in is if we want to enumerate objects, like for all instances. It's something that the JavaScript garbage collector does not give you as a primitive, so that is implemented by doing a manual garbage collect that just finds all the live objects that are still being used by the image, and then it can iterate through that image. The virtual machine is extensible by plugins, which people also make use of. The snapshot, so it's a regular Smalltalk. So you start with loading an image, you do your work, and you can save the image. It's stored in your local storage inside of your browser, and you can even export that back to your file system. And if you have a virtual machine that's compatible with the file format, with the image file, then you can continue to run that on a regular virtual machine. And so back then, it could run old Squeak images. So I will just show you, that if you scan the QR code, then you will be on this page. There is a mini image. This is the image that originally I was working with. This is a version of, why doesn't this go away? There we go. Okay, this is the mini image that Dan Ingalls did in, I don't even know, like late 2000, early 2000s. It's a 600 kbyte image, that's Squeak image that's very much stripped down. So it loads very, very fast. And so this was the first image that I got to run, but you can, on the launcher page, see a lot of images just to show the breadth of images you can run. And so that goes from the earliest Squeak image I could find from 1996 to a somewhat recent Squeak trunk image from last year. So I can show this here. Squeak used to be very, very colorful. So if I open a system browser, it's very, very green. Did I just close it again? Yeah, okay. But it's a real system browser. You can go in here, and the color choices, I'm not entirely sure. I might have gotten the color palette wrong, but I also wouldn't rule it out that this was the original color. I don't know if anyone remembers exactly. Other things that were going on here are, so eToys is working. I assume everyone knows eToys, so I don't really have to show it. No, okay, I see people shaking their heads, so why not? So if you go back to this main page, so there's an eToys demo here. eToys used to be an authoring system for kids that was used in schools a lot, and it has this tile scripting system. So this is the script that is controlling the car's movement, and you can see that the car is going on a circle, so it's forward, it goes forward 5 steps and then turns a little, and then it kind of bounces off the edges of the screen. But also, if the little blue color of the car, you can see it has a blue sensor at the nose. That one is detecting if it's going on to crash onto a one of the clouds here, for example. And what I can do is I can give this car a pen. I'm going to do the pen style a little bit larger, and I'm turning this to true. And now we can see the trail that this car is doing. So this was inspired by Logo and the turtle graphics, which was a very early computer system made by Seymour Pappert's group at MIT, and that taught kids about learning to program. So you had something like, okay, go forward 100 steps, turn right by 90 degrees, then go forward again. And if you do that 4 times, you get a square. And so this is the same principle. And eToys has a host of multimedia facilities. For example, one of the things that are interesting, I think, is that there was a spectrum analyzer where kids could learn about sound. So if I start this, now you can see me talking here, and so this is using a fast Fourier transform plugin, which was originally implemented in Slang, which is the subset of Smalltalk that gets compiled to C, but I compiled that same slang code to JavaScript code. So now this is running in JavaScript. And you can see if I whistle. Okay, I cannot really whistle, but I can make noise. So you see the white noise is everything in the spectrum. And it's fast enough to run here within the web browser. So the old images run very well. Let me switch back to my presentation. What else can we do? Oh, Scratch. So Scratch is a system that is very popular even nowadays. But nowadays it's the third version of Scratch. The first one was implemented in Squeak. The second one in Flash, and that technology died. So now the latest version is written in JavaScript. But in SqueakJS, you can run the original Scratch, and there's a special button for it. This is right over here, and there you go. And so you can say, okay, move forward 10 steps, little cat, and you can say, do this forever. So this is developed by someone who was in the original group of Squeak, and they were working on, so John Maloney, he was working on eToys before, and this is kind of like the commercialized, productized version of eToys. So it's a lot simpler to use. It's not quite as powerful, but people can, kids can learn this, and even the latest version of it looks pretty similar to this version. And I can just say, okay, use the next costume. So to actually see that this is Smalltalk, because it doesn't really look like Smalltalk, there's a trick. You have to shift click the loop in the R. And then you can turn the full screen off, and you get a little bit of the background. And in here, I can open a browser. And again, this is a very old Squeak. So this is hidden behind the scenes, but it is the real deal. So this is, again, a Smalltalk running in this Chrome browser here. What else can we run? We can run Pharo. So if you're interested in archaeology, you can go to the launcher, and I'm linking directly, so this is going to be the URL, and directly linking to the file server at Pharo, which has a latest.zip in the 1.0 directory. And if I click this, it's loading up Pharo 1.0. And one of the things that are in there, wait, let me make this a little larger, zoom in. It's not very pretty. Zoom in, okay, it's okay. So if I do, say what? Yeah. So Prof. Steph was the first thing that greeted you in Pharo. So I can run this and, hi, I'm Professor Steph. Do the next lesson. Next. And one of the first lessons is, how do you open a browser? So press Command D, and here's your browser that's not as colorful, but it looks a lot more professional. And yeah, again, you could actually use this to work in your web browser. And if you want to, you can run this on the phone. So everything I just did, you can do on the phone pretty much the same. Back to the presentation. All right, so that was kind of the state of the art in 2014 before the paper was written. And after that, I still worked on it and added support for closures, added support for a JIT compiler, for weak references and finalization. So all the bits and pieces that the old images don't necessarily need, but that newer versions of Smalltalk really make use of. And a very interesting feature is the JavaScript bridge, where you can call out directly to JavaScript. And so I will show you a little bit about the JIT compiler. So we go back to here. So this is easiest done in the environment on the Smalltalk zoo. So this is the Smalltalk zoo running. And this has a virtual machine level debugger. This is implemented in Lively, which is a Smalltalk-like system created by Dan Ingalls in JavaScript and for JavaScript. So this, it's the outside system here is not Smalltalk, but inside of it there's Smalltalk running. If I click the debug button here, you can see an inspector where you have the current method's bytecodes down here. So we just came back from the forced display update primitive, which basically puts a break into the main loop so that the browser can redraw the screen, and that's why we end up at this place when I break into it. Up here you can see the context stack, and this here is the current context. So we're about to pop this display screen off the stack. And on the left here, we can see the active context. For example, you can see, okay, there's a sender, and the sender of the sender, and the sender of the sender of the sender, and the sender of the sender. You get the idea. So this is the well-known spaghetti stack that's implemented as JavaScript objects. So you can see here, we have the first few slots in the receiver in this active context are instance variables. So this is the sender, the program counter, stack pointer, the current method up to the receiver, and then you have the variable length of the indexed variables. And so this is just the current stack that's in this context. And so if you want to explain how virtual machines work, this is an interesting teaching tool. I used it to implement the virtual machine originally for debugging it into existence, but nowadays it's really something where you can learn about it. Like for example, one interesting thing is a method in Squeak has both bytecodes and other. It has bytecodes and pointers, so it's a very weird object. But if I inspect this here, so this is a lively inspector for it. It has both a byte array and a pointer array. And so here, these are the 26 literals plus the method header. Those of you who ever looked into compiled methods, you know how this is implemented. So the JIT compiler, if I open the Chrome debugging tools, and I go and I step into this pop operation here, then we will get the is this large enough to see? Maybe a little. That's better, right? Then we step into the interpreter, and this is optimized code, so we don't get the real actual source code that I wrote, but it's a little bit smaller. So if the method sign flag is set, then it needs to use the sister bytecode set. That's something that I added later, but it's in the current VM, so that's why it's checking that. This one is not a sister image. And is this method compiled? Yes, it actually is compiled, so we will not go into the bytecode interpreter. This is the bytecode interpreter. If it's the bytecode from 0 to 15, it will just push one of the receiver's pointers, right? But we already compiled this method, so we're not going in here. But instead, we will go in here, which will eventually execute this method.compiled, and it calls it with this VM. So if I click on this here, come on. This is the actual compiled, the JITted code that we're running. And you can see that it's basically a big while loop where the program counter is the index where we jump to. So that's how you emulate a go-to instruction in JavaScript, because it doesn't exist. But at the very end here somewhere, there is our pop operation at index 133, right? And so a pop is really only decrementing the stack pointer. And that's exactly what the JIT compiler did here. So I can go in here. Actually, because we're in the debugger now, it will try to enable single stepping. So it will recompile this method. It did. And now if we jump into this, it will look a little bit different, because now all of a sudden we have comments in here. But that is just because we're in the debugger and it recompiled, it re-JITted the same method, so we jump here. And so it's getting a few variables out of the virtual machine that we can use. And now the PC is 133. We jump to this case, and the virtual machine's stack pointer was 15. And we decremented, and now the virtual machine stack pointer is 14. So it's very, very straightforward, and then we do return. And if I say I continue here, then we will see that the pop was executed, and the display screen will have been popped off. Boom, done. So yeah, we are at the 134 now, and this is the stack got popped. Okay, I got to rush. So the JIT compiler got implemented. The JavaScript bridge, okay, I have to show this. Because that's the thing that actually makes SqueakJS useful. Eric implemented the same thing we just figured out yesterday, but it's the way to actually interact with the browser. So I can modify the DOM object directly by calling JavaScript stuff with the Smalltalk syntax. So JS in this case here is a proxy for the global window object that is inside of JavaScript. And I can say, hello, ESUG. And this is a JavaScript level function that I just called. And the interesting thing here is I can talk to the DOM. So I can create HTML elements. So what I will do is I will create an h1 tag that says, hello ESUG. And I will position it above this canvas that we have here, and then append it to the body. And if everything goes right, then there's hello ESUG up there. And this is an actual HTML thing now, and if you hide this canvas, then this is how you can write an HTML application where you don't see any of the SqueakJS interface. Or you do what Eric is doing, and you use the headless version of SqueakJS, which doesn't even open this this window here. I can load libraries, so this is compiling some things. It's loading the jQuery library, and I can use jQuery now to hide the canvas, but I will show it back. See? I'll do it again. So this is just an HTML element that you can hide if you want. And you can also create more elements, like I'm creating a button. Here, I just created this button on top. And when I click the button, then we want to show hi in the transcript. So I have to open a transcript to see that this is actually working. And if I say hi, 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 hi. So every block closure that you add as a callback to JavaScript gets called back into the image. And this is how you build applications. Okay. Oh, I'm running out of time. So there was a lot more progress in SqueakJS. I added Spur support at some point. There's a network plugin by Fabio Niefaus there where you can actually load stuff from the web through the regular networking primitives. So Monticello works, it's slow, but it works. There is an incremental garbage collection now, which helps with the speed of when you do in all instances, so it doesn't have to do a full garbage collect. In 2020, Eric helped moving from the old Lively module system to the modern JavaScript ES module system. I added 64-bit support, so it's actually loading 64-bit images because everyone nowadays uses 64-bit images, right? And it gets converted on the fly to 32 bits. So the actual virtual machine is still 32 bits. And the same thing with the sister bytecode. So because a lot of images now use that, we had to support it. So I'm trying to keep SqueakJS as compatible as possible. And the latest thing I did in SqueakJS is I added FFI support, which is weird because FFI is calling out to C normally, and there is no C in the web browser. But I needed that to get my last little demo running, which is this here. It's the old croquet from 2004 that Alan Kay used in his Turing Award speech. And so if you go to this GitHub repository, there's some explanations on how to actually launch the demos, but here it is. And this is, if I go into full screen mode here, full screen, you can move around. Yeah, you have these portals here. You can open a portal to a different world. You can peek inside what is inside this world here. And you can actually go through this portal. And now you're in the other world. If you remember this demo from 20 years ago, or you watched a YouTube video, that's also possible. You will recognize this. And we can walk out back into the world where we came from. And so for this to work, I had to implement a whole new OpenGL implementation because WebGL is not compatible with OpenGL 1.0. And yeah, so this is 3,000 lines of code of actually implementing the old OpenGL state machine, and this is called in through JavaScript, through the FFI. I've also started on a TCP/IP emulation. Apparently nobody implemented TCP/IP yet in JavaScript. Can't imagine why. And so that is unfinished. So I just showed Croquet. Plop, if you remember that, it's a commercial application that was sold on CD-ROM in the early 2000s. It won an ESUG award at some point. So that is working too, again, so if you can run this on your phone now. And just to round it out, what's the future of SqueakJS? I'm hoping that more people will run applications, so some people see the appeal of having a fully compatible Smalltalk machine that is running in a web browser. I just saw yesterday someone was using Code Paradise for another application, so that's pretty cool. A faster JIT would be interesting. I showed you the JIT that we have, but it's not, it's only accelerating bytecodes and not really the sense, and sense is what's really important. It would be cool if I could export a 64-bit image, but I'm not doing the back conversion on saving. I could do that. That would be interesting. The network plugin I manage, I mentioned. Sorry. And what would be cool if I wrote a native app as a virtual machine, because, for example, right now there's no way to run eToys on the Mac in a native virtual machine because everything is 64-bit and it doesn't run the old 32-bit machines anymore. And so just having an app to run this stuff would be cool. So thank you so much. Sorry for going a little bit over time. And find me in the hallway if you have any questions, I would think. Or do we have time for?
Yeah, maybe 1 or 2 questions.
Okay.
Thank you, Vanessa, for the presentation and the very impressive work. My question is that you have performance issues. There are performance issues in the browser to deal with, and you deal with quite well. And I was wondering whether you have some, what design decisions or strategies you adopted to deal with the performance. So to have like the image working very reactive without delay, and
yeah,
even if you have layers of interpretation there.
Right. So it's fast enough for many things. Like in Code Paradise, if you just create some HTML and you show it and you click on a button and something gets executed, that really is fast enough. The JIT compiler helps a lot. I think I got a 10 times speed up from when I introduced that. And I do have a design for a better JIT compiler that you can read about here in the change log somewhere, like last year, like advanced JIT mockups that I did for leveraging the JavaScript JIT compiler better. And I think that could be another 10 times speed up. And with that, I would be pretty happy. It will not be as fast as like the real high performance virtual machines, but you could do some more optimizations if I had the time. Like right now, it's only a hobby project and I don't have the time for it. Sorry. One more? I don't know.
Hello. Maybe I'm a strange duck in the sense that I dislike web programming. So what I do like is having a full UI, basically, without any web programming. So I think that's, I don't know what, if for Faro, for example, the new one, you have block in the as UI. I don't have the knowledge in terms of architecture, but would it be possible to, run that in a certain moment, or what would be needed to do that?
So the question is?
Yeah, so having a full Faro, I don't know, 12 or 13 on this.
The current Faro doesn't run out of the box, it loads. So you can take a current Faro image and throw it into the VM and it starts up. But my guess is that a few primitives are missing that Faro needs. Also, Faro uses FFI to call directly into some system libraries, like I don't know, maybe it's libstl, which is used for rendering or so. And the way to implement that would be, I do have the FFI, so that part is is already done, but you would have to emulate whatever features Pharo needs and make that work in a web browser. One idea would be, for example, to take libstdl and compile it to WebAssembly, and then use the FFI to call into that WebAssembly thing. Yeah, if anyone wants to do that project, I'd be happy to mentor it. So yeah, it's possible for sure. It's just a smaller bit of work. Thank you.